All right, we're starting off here with our first method for solving logarithmic and exponential equations. And our first one is to basically start by, if we can, making our exponentials have the same base. And if we can do that, then we'll basically know then that the two exponents must be equal to each other. All right, so if we can get them to have the same base, the two exponents will be equal to each other. So if I have 2 to the x minus 1 equals 2 to the 3, then I know that x minus 1 is going to have to be 3, otherwise they won't be equal. So this is the kind of idea we're doing here. If I had something like 2 to the x minus 1 equals 3 to the 3, then I wouldn't be able to say, then I wouldn't be able to say that x minus 1 equals 3. Like that I wouldn't be able to do because the bases aren't the same. And so after you do that, you can then just solve for your variable and move on. So let's try a couple of examples here. So we look at this first one, it's 3 to the x equals 27. So these do not have the same base, so I need to make them have the same base. 3, I can't really change the base on it, so I'm going to end up leaving it as 3. But 27 is actually just 3 to the third power. 3 times 3 is 9, and then times 3 again is 27. And so since that's the case, I can then say the exponents equal each other, and I get that x equals 3. All right, and if you plug that back into the original one, 3 to the third is 27, so it worked. This one, we can see here, we have 2, and then I have an equals 1/8. Well, I can make 1/8 as 2 to the third power. 2 times 2 is 4, times 2 again is 8. And then what I can do is write this as 2 to the x equals 2 to the negative 3. Because since we have that as a fraction, I can take the reciprocal and make the exponent negative, just like that. And so then that tells me that x equals negative 3. All right. So let me do one more here. Let's do number 3. So on this one, I see I have an 8 there, but I can't write 32 as an 8 to some power, at least not easily. It is an 8 to some power, but not like a whole number, or even an easy fraction there. So what I can do is I can look at this and I say, well, I can do 32 as a base of 2. And I can look at this and say, all right, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 again is 32. So there's 5 of those 2's there. So that 32 is actually 2 to the 5th. And then it's still to that x power. And then 8 is just 2 to the third. 2 times 2 is 4, times 2 again is 8. And so this is what I have. And if you remember, anytime you have something like something with an exponent to another exponent, you ultimately just end up multiplying the two exponents together. So this will become 2 to the 5x equals 2 to the third. And if you're ever unsure, should it be 5 times x or 5 plus x or something like that, think of an easy example, like say maybe 2 to the third, to the fourth. If you look at that, that's 2 to the third times 2 to the third times 2 to the third times 2 to the third. And so you end up adding up 3 plus 3 plus 3 plus 3, and that's 2 to the 12th. And so that 12 is the 3 times 4. So whenever you have an exponent to another exponent, you multiply those exponents together. So continuing on down, I can set the exponents equal to each other like that. And then I'll get that x equals 3/5, just like that. Okay. So not too hard there, not too crazy. What I think you should go ahead and do is maybe, well, let me do one more for you and then I'll let you try because I think there's some more on the next page. Yeah. So let me show you just one more just to make sure we've got it. So here we're going to do, we have a base of 2. I can write that 16 as a base of 2. So I'm going to leave this as 3x minus 8. And then the 16, 2 times 2 is 4, times 2 is 8, times 2 again is 16. So that's 2 to the 4th. It took me 4 2's to get there. And so I can say then that 3x minus 8 equals 4, which tells me that 3x equals 12 by adding 8 to both sides, and then divide both sides by 3, and you get x equals 4. All right. Oh, up here I added 8 plus 8 plus 8 like that. Okay, so there you go. What I'd like you to go ahead and do is go ahead and try the ones on the next page here. See how you do for it. All right, so here we've got all the ones done on that page where we went through and did them. And so if you need those, they're right there. Now on to our next method here. And in fact, this method will work for all the previous problems we've done. If you can't think of a base that matches for them, like you think maybe there isn't one, even if there actually is one that matches, this method here will still work. So the first thing you're going to want to do is isolate the exponential if you need to. So like right here, you can see in this example, 3 to the x equals 25. There's no way we're going to make those have the same base, but the 3 to the x is already isolated. It's not by itself, or I mean, sorry, it is by itself. It doesn't have anything else with it. Then what we're going to do is take the natural log of both sides, and then we're going to try and simplify it using one of these properties. So first off, we could use natural log of b to the x equals x times the natural log of b, or natural log of e to the x is just x, because natural log has a base e, and so that would be log base e of e to the x, and they would just essentially kind of cancel out the base with the exponential would. Okay, so I'm going to quickly show you here 3 ways to do this one. Really, you're pretty much going to mostly want to stick with this natural log method, but the other methods will work, and I'm just going to kind of show you it so you know it, and so that you can see that it's very consistent. So if we start with natural log, the exponential is already by itself 4 to the x. So I'm going to take the natural log of both sides. What you do to one side, you do to the other, just like that. Then what I'm going to do is bring this x out in front, and it'll be x natural log of 4 equals natural log of 15, just like that. And then I just divide both sides by natural log of 4. So I'll get x equals natural log of 15 divided by the natural log of 4. And you could type that into your calculator and get an answer. Do not cancel out the natural logs. Those are operators. It isn't natural log times 15. It's natural log of 15. So do not cancel out the natural logs there. But you could type that into your calculator and get a number. But otherwise, that's essentially our answer right there. If it's multiple choice, you may very well get the answers that look just like that, so you don't actually have to use a calculator. Usually, I have found the best quizzes and best tests on logarithms are the ones that don't require you to ever have to use a calculator. All right. Or what we can do is we don't necessarily have to stick with the natural log. We can actually use any log we want. So I could use log base 10 of 4 to the x equals, again, that log base 10 of 15, and then just go through and do the same sort of thing. Bring that x out in front, x log of 4 equals log of 15, like that, and then just get x equals log of 15 over log of 4. And if you type that into your calculator, log of 15 over log of 4, it'll be equal to the natural log of 15 over the natural log of 4. So you'll get the same answer there. And then I'm going to show you one more time. Since we can do any base we want and have this work, this one is maybe a little easier if you have a calculator that allows you to type in logarithms with different bases. Then you may want to do this. You may want to match the base of your log to the base of your exponential. Because when you do that, you end up just canceling out those and those, and you, or canceling like in quotes, but they actually undo each other, and you just end up with log base 4 of 15. And so this answer and our first answer over here, if you plug them into calculators or do them out, they're actually all going to give you the same exact number. So any one of those 3 methods will actually work for solving these, but we're going to mostly stick to this one. But I just wanted you to see the other ones in case you ever encounter them other places. But there you go. We're going to stick to that first method with the natural logs. not really these other ones. So you don't really need to remember those, but now you've seen it at least. Okay, so let me do one more example for you here. We have, or maybe I'll do two more. So we have 7 to the x, the exponent is already, the exponential is already isolated. So I just take natural log of both sides. Okay, bring the x out front. X times the natural log of 7 equals the natural log of 10, just like that. And then divide both sides by the natural log of 7. So natural log of 10 divided by the natural log of 7. And there's your answer. You can stop right there. All right, unless your multiple choice answers are in decimals, in which case you need to type it into a calculator. So I'm going to do one more for you before I let y'all try these, or we try them together. Let's look at number 15. Here we've got 9 times e to the x equals 107. Well, I don't have my exponential isolated. So we actually have to do the first step, and that's divide both sides by 9. And I'll end up with e to the x equals 107 over 9. I can't reduce that. If it was 108 over 9, then it would just be 12, but 107 doesn't work. That's going to be like 11 and 8/9. So I'm just going to leave it like that. And then I'm going to take the natural log of both sides. Just like that. And as we stated up here, the natural log of e to the x is just x. So when I come down here, I have natural log of e to the x, so that's just x. And so my x value is just natural log of 107 over 9. All right, so I'm going to give you a couple of minutes to go ahead and try 13, 14, and 15 before we move on. All right, there you go. Here are all the solutions for this page, if you can read my writing down in there, except for number 16, which I guess I could just show y'all real quick if you wanted to try it yourself. It's just a matter of natural log of e to the 5x equals natural log of 15. And then this natural log will basically cancel with that e, and you're left with 5x equals natural log of 15. And then it's just x equals natural log of 15 over 5, just like that. Okay, so just so we have that one, there it is. All right, next page. What do we do if we have a logarithmic equation? So far all we've done is exponential equations. In fact, actually, before we do that, I want to go back here real quick and just pick one, like say number 7, and say what would happen if we didn't realize we could have written that as the same base? What if we had tried to do natural log of 4 to the x equals natural log of 32? Like what if we had tried to do it with the method that we had just done? That's actually going to just give us x times natural log of 4 equals natural log of 32, which just gives us x equals natural log of 32 over natural log of 4. And if you type that into a calculator, most calculators would give you then 2.5. And 2.5 is equal to 5 over 2. So even doing it this other way, you're still going to get the same answer. So even if you don't realize you could have done the same base, it's still going to work out for you if you use this method here. All right, so now back to this. What if we don't have an exponential, but instead we have a logarithmic? Well, that's where you're going to use this whole just switch them around kind of thing. If you don't like thinking of the switch around where you take the b and you move it out and put it to the y power and then it equals x kind of a thing, where we're just rewriting in that form. If you're more like me and you prefer to think of what you're actually doing, it's really more like you have y equals log base b of x. And what you're doing is putting both sides as exponents for a log of base b. So you're matching the base of the logarithm with the base of an exponential, and then those will cancel like that. And you're left with x equals b to the y. So if you prefer to think of it that way, that's fine. Otherwise, just skip down to the third step and just do the rearranging to make it match that. So so our overall step is going to be use all our properties of logarithms to condense it down to a single logarithm, if you have to, if it's not already done like that. And then rewrite it after you have it as a single log like that. You're going to rewrite it into that form and then solve for the variable if you have anything left to solve for. All right, so let me show you number 17 here. So what we can do is take this and rewrite it in our form. I won't go through doing the whole thing I did up here. I'm going to skip this step right there that's in the middle. So we're just going to go ahead and rewrite it. That will become 4 squared equals x plus 3. 4 squared is 16. And then this equals x plus 3. And then I'm going to subtract 3 from both sides, and we'll get x equals 13. All right. And so now at that point, I'm not going to put a box around this because our last thing we have to do is we have to check to see if our proposed solution, so this is our proposed solution here, if it actually does work. All right. And by work, what we mean is for a logarithm, what we take the log of has to be between 0 and infinity. We can't take the log of 0 or of anything that has a negative in it. So we have to make sure that when we do this, we are staying inside the domain of our logarithm. So we basically take and check it by plugging it back in to see if it works. So I'll plug in 13. I'll get log base 4 of 13 plus 3 equals 2. And so this is log base 4 of 16 equals 2. And yes, that's true. This works. We're not taking the log of anything that doesn't, that's a negative or anything like that. And this tells us that 4 squared equals 16. So yes, this works, which means yes, that's an answer. Okay. So there's that one. Let me try number 18 here for you. So for 18, what we can do is go ahead and rewrite this as 2 to the third equals x plus 20. So 2 to the third equals the x plus 20, just like that. And then solve for it. 2 to the third is 2 times 2, which is 4, times 2 is 8, equals x plus 20, which means we end up with x equals negative 12, because 20 minus 8, I'm sorry, not 20 minus 8. 8 minus 20 is negative 12. All right, so that's how we got that. We subtracted 20 from both sides. So x equals negative 12. That's our proposed solution. So then you look at this and you say, wait a second, that's negative. We can't have a negative. Well, you have to be a little more careful than that. It's not about whether or not x is negative. It's about whether or not when we go to check it, whether or not we end up taking the log of something that is negative. And you can see here, when we plug in negative 12, we get negative 12 plus 20. So we end up doing the log of positive 8, which is perfectly acceptable. And it's also true that then 2 to the third equals 8. So yes, this works, which means we can go ahead and accept that as an answer. Okay. Look over here. I'm going to leave 19 for you to do, but while I'm doing this, I'm going to go ahead and show number 20. For number 20, this one, we have to go ahead and use properties of logarithms to condense it to a single logarithm. And so I'm going to do that by saying, all right, this is a log base 2 and this is a log base 2. So that means I can combine them using the old log rule of log base b of a times b is equal to log base b of a plus log base b of capital B. And so we're going to use this rule in reverse. We have 2 logarithms being added together with the same base, which means I can combine them into one, which this will be log base 2 of x times x minus 7 equals 3. All right. And then I can distribute. This will be log base 2 of x squared minus 7x. I just distributed this x through, equals 3. And then I rewrite it. 2 to the third equals x squared minus 7x, just like that. That 2 to the third is actually an 8. So I can write this as 0 equals x squared minus 7x minus 8. So that 2 to the third was an 8, and then I subtracted it from both sides. And now I have a nice little quadratic function here, and I can just go ahead and try and see if I can factor it. So 0 is going to equal x minus 8, and then x plus 1, because negative 8 times 1 is negative 8, and negative 8 plus 1 is negative 7. So that works for us as a factoring. So that means our two solutions here are x equals 8 or x equals negative 1. These are our two potential solutions. So the only thing left for me to do is to check both of them. So let's check 8. We go ahead and plug that in. We get log base 2 of 8 plus log base 2 of 8 minus 7 equals 3. Log base 2 of 8, well, 2 to the third power is 8, so that's just a 3, because 2 to the 3 equals 8. And then this becomes log base 2 of 1. And so we ask ourselves, 2 to the what power equals 1? And then that just turns out to be 2 to the 0. So we end up with 3 plus 0 equals 3, and that works. So 8 worked. What we need to do next is check negative 1. And here, if I plug in negative 1, I get log base 2 of negative 1, which is automatically a problem, plus log base 2 of negative 1 minus 7, which again is a problem because this is negative, and we can't take the log of a negative number. It's outside the domain of a log. So no log of negative numbers. So this doesn't work. So this one doesn't work, which means that answer doesn't work, and this is the only answer that will work for us. All right, so I'm going to go ahead and pause this and let y'all have the last minute here to work on these.